Okay, now that we have set up the axis, we can start creating the actual plot. So we can start create like the data using like real data, giving some colors, the labels, and so on. So the first thing we want to do is to download the data, and I'm going to use the Pokemon dataset. I found it on Kaggle, um, but um, for reasons I will explain later, it's better if you use the data that I have already cleaned. It's on my GitHub, and I will show you in a bit. That's also because when we will do the interactivity section, we will also need the images of the Pokemons. So I already match the data and the Pokemon with the images. So it's better. You can also use your own data, but it's better if you use the one that I have cleaned already. So let's do this part now. To download the dataset, you can go to my GitHub repository. I'll share the link. And then you go to data and Pokemon. And you can download this CSV Pokemon file. Also note that this dataset comes from this Kaggle dataset. I will share also the link. There are many more variables here. I already selected only a few of them, the ones that we're going to use, and clean them so we can start. Okay, now that we have the data, we can start using them. So we can create another base here, this, and we'll call it data. We can go inside, and here we can start creating our data operators. So first of all, there are two ways to like load the data set. Like the best one is just to create a table here, that table, and then here in file in the plus you click and you go get where you have saved the data. It's better to put them in the same folder of the project, but that's up to you. And I will choose my dataset. Okay. So that's like pretty much like a CSV table. It's not much different from any CSV table you can find. But the good thing is that we can start working on it with the TouchDesigner operators. So first of all, let's add a null. It's always a good thing. And then we can add a DAC2. So we can go here. We can also work only with dots, but I prefer, and it's also more efficient to work with channels, with chops. So now it's still not working because we need to change a few things. We go here and we change these in channels per column. Then you can check here. So the first row is names, so it's like the variable names. And the first column is values. So we don't, like if we had an index, for example, we could use it as names, but we don't have. And now we can, as you can see, we have all our variables like already translated in channels. We add another null. And then we want to select the variables we want to use. So like here we have, also, of course, in our scatterplot, two variables, x and y. And so we can add two select jobs. One will be the x and one will be the y. So we can copy paste and call it y. Now in the x, we can just select the one we want. So let's say we want to check, I don't know, correlations between attack, and in the y we can choose, I don't know, something weird like hate. Shouldn't be, but let's see. Now, to be consistent, and like for reasons that you also see later, we can rename them. So we add a rename here and a rename for the y, and we rename both them like x and y. So as you can see now, our channels will be called x and y. It's difficult to see, but it's here. Now, We can add a merge. It's still not enough, but let's just take a look of what will happen here. So we have the two channels here, X and Y, and we can add a null, of course. That's what will represent our data position at the end. So like the dots here. So we can call it just data pos. And then we can go to our the geo here. Actually, it's this one where we have our dots. Now we are using just a random noise to create the dots. So we can go here to the geo, and in instance we can use instance like the first page of instance. In the translate OP we can put this new null we created and we drag it here. And then now we have to give the channel values. So now we have created them as capital letters, so X and Y. So now these dots got the positions of our like attack and hate. Now these values, as you can see, are quite big. So they go from 0 to, especially the X, the attack, from 0 to 200, while our Cartesian X goes from 0 to 1, more or less. We need to rescale this data. And we have one operator for this. So we can insert here and add a limit. And like in the new version here, it's very easy. We can just do normalize and move the values from 0 to 1. And we do the same here. And you do normalize on values from 0 to 1. Okay. Not very nice. There's also I still see some correlations. But to have something nicer, that also easier to look, maybe let's choose, instead of hate, something that we know will be correlated with attack, which can be like defense, I guess. And oh yeah, we have an error here. We need to change this. And okay, now we have like this kind of correlation. Of course, it's attack and defense. And okay, so the base plot is ready. And then we can keep working on it. For the record, I realized that the table I was using had a double attack, you see here. So in the next video that will be fixed. Okay. And the table you'll find in my GitHub is already corrected. Okay, now we want to add some colors to the dots. So let's add like a single color for now. That's pretty easy. So we can move this gear here. So just down of the axis, and the circle also here. So we can move this constant inside, I prefer. So we can go inside and create a new constant. And call it like markers color. And we can give it like color that you like, something like this. We go up in the gear, in the render, and in the material we have to refer to that new constant we created. So we can go down, it's like dot slash, and then the name of the operator, which we call markers color. Okay. So then they're colored. But that's pretty basic. But let's say that we want to like create a gradient of color based on one variable. So let's say that we're using attack and defense, and we want to color them based on hate. So to do that, so you can go inside data. Actually, we stay here, and here we have X and Y, and we create a new one. So those are select, create a new select chop, and connect it here. And here we choose the hate M. Now, we go up and we create a new base here where we will control the colors. Now these two are quite empty now, but will be filled at the end. So we call it color, and go inside. So now we get that job we just created. So we can create a select, and so to get it, we can go, like, we can use this window, go up to data, and we drag this one here. So it's like copying this one, and we call it also with the same name, like color var, variable that will color the markers. We can create, for now, just something very simple like a ramp, and we can create the shade of color we want. So we don't need here in the, the resolution, we can have only like 1 on the Y, so it's like a line, and it doesn't really matter for now. It will matter later. We can choose our colors. So let's say that we go from this green to, oops, yeah, from like a green like this to a blue. This will translate into a dot, top 2. And so like we have the channels of our RGB colors now. And we can create a lookup, and the lookup will take 2 inputs. So we drag also the top, this channel here. It's basically mapping our variables here, like the height here and the values, through the RGB colors. Now we also want these, like, we have 251 samples, but they should be the same number of these. So we have 800 Pokemons, we need 800 Pokemons. So we go to the ramp, and in the resolutions here, we can just grab this one, color var, put it here, and we add dot num samples. So it's basically taking the number of samples, like the number of dots or Pokemons, if you want, and use it here. So like now we have a line of 801 samples that are mapped into RGB here. We add a null, and we can call it colors. Now we go back up to our geo, like the markers, and we go to instance 2, the second page, where we have texture chord OP, and we drag our colors operator here. And now we just add RGB. Oops, my mistake. It's not the texture. It's the color OP, of course. So we can delete this and just do the same here. RGB. Okay. So it's like taking shape now. We can take a look. If we go here into geometry viewer, we can like explore a bit. So if you probably you understand what's happening, but so the idea is that the Pokemons with low, like the shorter ones, in terms of height, are green, and the highest one are blue. So we see that when attack and defense go up, also like the height raises. Okay. Okay. One last little piece to finish the base plot is to add the background. So now we have like black, like a black screen, something like that. and we want to add okay, white maybe or gray background. So we go up and we create another base here that we call background, of course. And we can go inside and we can start creating like a texture for a background that we will use in a bit. So we create constant, for now just a constant. Maybe we can put like a bit more gray to not blind soon. And of course not. And this will be like the text, maybe like background texture. And now we go up, and like before we create a new geometry, but for this we want like a rectangle here that stays behind our plot and like color the background. So we can create a rectangle connected to a geo, of course. Of course, not enough. We need to center this. If you remember, like the way to center it is to take the size and divide it by 2. And we do the same for the y. We just need to modify the name here. Okay, and then size, you can experiment a bit, but maybe like 1.5 and 1.5, or maybe 2. Now it's like centered, starting from the origin, which is still not good for us. So maybe can reduce this of like 0.5, and this one also minus 0.5. That's already better. Few problems. First of all, you see in the view here, in the geometry viewer, that some like they are overlapping the dots with the rectangle. So we can go here, and in the translate here we can go like minus something very very small, like 0.001. Okay, then okay, first thing, we need to color the axis. This is horrible to see, so we can go into the first geo here, geo 2 actually, and we create a constant, this, color it black, and this is like axis color. You can call it as you want. We go up here into the geo 2 render, and the material will be dot slash, so go inside color axis, axis color, right? Choose the wrong name. Okay, now you can see it. Okay, it's a bit better. Okay. Okay. And one more thing to make it nicer is to assign the size of these dots to a variable. So this we can go up one more. We don't need to create a new base because it's just basically one operator. So we can go inside data, and we can create another select like this one. So it's like using another variable to control something. So this is, let's change that to select. Then we want to resize the values. So like it will be the values of these dots. So like let's resize it from something small. So we can use a limit. We can do like like go normalize from like 0.5 to 1. Let's try. And we use a null. And we can call this null size. Now here in the geo1, the markers geo, we go to scale of p, and we assign the scale of p to this new null we created, the size. And actually here we can choose something else, like HP, for example. It's like the life of the Pokemon. And we choose it also, or maybe like to be sure, we can also rename it to size, because we change. And so we can choose the size here and here. So let's take a look. So you can play also with the size. So maybe like you can do 1.5, and maybe like this is smaller. Like it's up to you. I will leave 0.5 to 1.5. So I realized one more thing that I didn't do before is that we need also to rename this color over here, this operator, so we can call it back to select small letter. Yes. We can use the rename now, and this will be from anything to color, maybe color var. To be consistent, use the same we used here to rename like size. So we just color is fine, and we add a null as usual. And now this will be like the color var. And now if we go up and we go to color, now this is getting the select one, so now we can take the color var. Okay, so now the the channel name is color, and the reason why we do this is that, like, I'll show you. If we go to data and we change the variable here, like attack, this will be still just color, like here. One other thing I'd like to do before like automating everything is to make the background a bit nicer. So now it's not that good, it's just a gray flat area. We can go up here, and we go to the background. So now I'd like to create like a background, like ggplot style with a grid. So to create the lines of the grid, let's start with the top rectangle, this, and let's modify also the resolution to like 180, 1280, 1280. So it's like high resolution. Then I want to modify this rectangle in like a line, so we can have like size x size like 0.05 and y size like 1. So we have this line. We add a transform, and in this transform we can modify the scale. It's like 0.02, and this is fine. So if you go closer, you can see what's happening. And then we go to tile and have a repeat. And now we have like the vertical lines. Okay, now we can do the same for the like horizontal lines. So we can even just copy paste this one and rotate 90 degrees. It's also fine. Now we want to like merge these two so they're together, and the way we merge two tops is composite top. So go here. The way to, so this is like the operation that is applied between the two tops. And like every pixel is the operation between the RGB of the two tops. So now we can try with the maximum. Maximum. Okay. And so we have the grid. And then we want to merge this one also with this background. So we can add here another composite. This, and add this one here. Now we want to create the like horizontal lines of this, so we can copy paste this one and just like rotate 90 degrees like this. And then we want to merge these two tops. And the way to do this is create a composite like this, and we will input both the tops. There are many operations here we can do in the operation here, and that basically means like for each pixel do this operation between these two. So like multiply is like taking the values of this pixel for the first pixel here. So we can use this like over, means like we have both of them together, and then we take this like first background we created and we create another composite here, and we input this one here, and also here we want to use over this. Now we created this rectangle as like 1280, 1280, so we have to have the same values in this constant, so we can just copy paste here. And we can modify, switch the order of the two inputs. So if you go to the composite here, you can just use this arrow. So now like this one will be on top of this one. And so we have our grid. And let's say that we want to play with the colors. Like these can be a bit more, like a bit darker. This one can be white or whatever. Okay, and that's up to you. To finish this part, let's go up and let's color back this plot. So let's go to color. So there's one thing missing here, and from the color var select to the lookup. Still need to normalize the values. So we add a limit and normalize the values from 0 to 1 as usual. Now maybe it's like here in the, let's go back. So let's go to data. Here, this select is where we choose the color, like the variable that will control the color. Maybe let's use something that is not in the XY, like HP, something like this. And let's get rid of attack, just HP. Something like this makes more sense. And let's go up. Let's get rid of this viewer here. So we have it here, and it's almost ready. So we have like our base, like base plot to work on. What we will do now will be to automate all these values, like being able to control all these values from the master operator, like we did with the Cartesian axe, the ticks, and the ticks table. We want parameters here that allow us to control all this. But for this now, things are a bit more complicated, and we will need extensions.